Okay. First of all, what is data and why that? The first topic I'll be just covering. So, the purpose of data engineers and what is data. So, as I told you, that data means, the collective information, whatever information I'm getting from each of the enterprises. So, nowadays, you can see for each of the enterprises, suppose the enterprises, maybe it's a pharmaceutical enterprise, or maybe it's an insurance company, maybe it's a banking industry. So they're doing some transaction with the users. They should be having their own business users. They should be having their own clients and all. Suppose you are banking customer. So bank has all the information about myself. Even bank is having all the transactional details, what I'm doing over there in bank, what are, my personal details, my transaction details, everything they're also capturing over there. So those are all, all the things are nothing but data. They're collecting all the information of data. From me is data only. Suppose, suppose I'm a owner of a particular shopping mall. Okay. So I'm collecting information from all the users. I'm collecting information from I mean, all of my employees. I'm owner of the shopping mall. I have lots of employees over there. So I have all the employees details. It's stored into some databases. I have all the information about the transaction, how the customers are purchasing in the particular purchasing bill, what are the quantity, what are the particular items I have purchased. The customers have purchased and all. Every information we are storing it in the form of data. So that is how the data is getting stored. Okay. In the data, it can be quantity. I'm storing some quantity, some quality, facts, statistics, all the things I'm storing. It's called data only. Now, what the purpose of data engineers? They're storing the data. Why we're storing the data? What is the purpose of it? Because the main fundamental things, and this is one of the main things why the data engineers is a hot topic nowadays. Okay. On top of data, data engineers will be helping to get the hidden trends of the data actually by reading out the data. When the data is in meaningful format, the data scientist or data analyst can read the data. On top of this data, they can create meaningful charts and graphs, and by checking these things, the business owner or the product owner, they can take easy decisions. They can change their strategy for the next quarter. Suppose I am having heavy loss over here into my next, in this quarter. I'm a product owner. I can see, there are lots of production actually in from the manufacturing unit. That is fine, but and there is very less revenue comparing from the last quarter. Okay, then I need to check what are the issues happened over there. By checking the reading, by checking the data, by reading the data itself, they can understand what is the issue. So that is the, magic of the data. They can check the hidden trend, hidden pattern, what is causing the issue, and they will be try to resolve the same thing, so that from the very next day or from the very next quarter, their revenue can go increasing. Okay. So purpose of the data engineers, they're collecting the data from the source side. Source side means, maybe at the very beginning, suppose in a particular shopping mall, they're taking all of your information and putting into some system. Maybe there's some UI interface are there. They're putting everything in your system, and the data are getting stored into some databases. Okay. Now, data engineer scope should be starting from that database. They're collecting the information from this database, and as I mentioned, they're doing some, they're handling the ETL tool to store the data at the target system. Target system means some data warehouse or data mart. And then the visualization team again, or data analytics team, they are again taking the data and creating suitable charts and graphs. Okay. Maybe some data scientist teams are also there. They're also taking those data, meaningful data, and creating probabilities. What kind of probabilities? Not only probability, they're just checking or forecasting the businesses as well. Okay. On top of this good data, actually the data which is stored in data warehouse, data scientist, Okay, let me just give you a practical experience. So when I was working in a particular company, some life science company, it was J&J actually. Johnson and Johnson was my client. That time they're creating some some probability function. Just like I was working in pharmaceutical sector of J&J. Okay, there is lots of sectors in J&J. There are commercial sector. They're selling some baby care products and all. There are medical device products. They're selling or they're handling lots of, just like contact lens of eyes. They're selling insulin products. Lots of things are there in J&J. I was working in pharmaceutical sectors over there. They have their own medicine products and all. Okay, medicine brands over there. So while working in that particular things, data scientists, they are creating some suitable logics and all, by which they are able to find a particular patient's probability to live, or to, a particular, leaving the particular company's medication. Okay, so they're getting the probability just like 97% of that particular patient's probability to leaving that particular company's medication. And really it happens in the next day. They're having 97% of the probability, and a very next day the particular patient left the company. So now the strategy, or business owner need to have some good strategy on that, they're checking from customer satisfactory index that it's not good from their side, even from the medications and all, even from the review of from the customers and all, they're checking they're not quite good. They need to take then the decisions to make them happy, or to make some extra care to that particular patient. Just like this, they need to take good strategy on top of that, so that they can take, or they can help the patient to bring back with their own way, or own satisfactory way, to have join back to the medications again. Or they can give some extra offers for these patients and all. So it's totally on top of the business how they will be treating it. But as per the data team, we just need to present those kind of analysis in front of business owner. Okay, our scope is still that thing, from the source system to the target, or maybe to the visualization, or maybe if you are working as a data scientist, you will be having those suitable calculations. You are creating those probabilities in front of business users. Now it's totally on them, the business user or the business owner, how they will be treating it. If one or two patients are living out, there'll be no issue from their side. It's totally their revenues and all. If they're, putting every customers, or each of the customers, they're putting the same focusing area, then they will be taking the decisions, or they will be changing their mind to catch each and individual customers. Okay, but it's not data engineer scopes, it's totally business scopes. Did you get it? Any doubt? What is the purpose of us? Ask me. I am also a database engineer. That's why I'm telling myself as a database engineer. Okay.
So before like Power BI or ETL, which tools they use to extract the data?
Before means, before why before introducing of this Power BI or Tableau, how they're extracting the data, is this?
Yes,
I didn't get you.
yeah, that's correct question. Yeah, that's what I
Okay,
asked.
when the particular actually data, maybe data was there earlier, they used to have some Excel or some other way, some paper or any other way. Data also, it was in picture on 2000. It started with a huge scale of data industry and all. It's coming into the picture from 2000, maybe 2010 or 2008. Okay, data was there earlier as well, but it was not so much popular. Earlier it was Java or any programming languages. They're focusing on web development. Those are having, big. a demand of on top of that. But nowadays, I mean, people are going ahead with how to forecast the business. If we are going in this way, we can easily forecast that after 1 year, our business or our revenue should be this. We can quickly forecast it. Means we are seeing our future only in the business. So that is why nowadays this is very, very important. Before that, it was not so good. Actually, they're not focusing on top of this area. So in pen and papers, they are just having this kind of things. There are mathematics, they can have these things, but that is not in large scale. Okay. But nowadays they're focusing on top of this. They're using those kind of tools and all to have this very easy. They do not have to put effort with pen and papers and all. Okay. But it's, I mean, having more than 15 years or nearly to 20 years of data. I mean, when it's going ahead with large scales and all, it's having data. I mean, having lots of importance on top of this. And the business owners, they're giving importance over here because this sectors, I mean, will helping them out with larger revenue. Okay. 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 So different, I mean, I already mentioned this thing. So each of the enterprise, they're using their own data engineer teams because of those are required, just like for banking industry, they're checking their business growth. Each of the industry, they're checking how to have some more business growth by checking the data only. Okay, data pattern, the particular customers, how they're purchasing their product, how, I mean, what are the credit limit or debit limit, or how the credits and debits transactions are happening from each of the customers. They're looking everything. Just like in banking industry, I'm telling over here. Similarly for insurance, commercial industry, medical, pharmaceutical, each of the industry, they are just doing their own businesses to store the data or to checking the data. They want to enhance their business growth and all. So that is why each of the enterprises, they're focusing on their on this kind of data topics. Okay. Moving to the next slide. Okay, now it's a bit technical. So when we are storing the data or when we are fetching the data from any kind of data sources, okay, data is getting stored in databases. Either in this format, you can see there are two formats I have mentioned, but the data is same. So I'm storing two records over here. One is Ram, another one is Bob. I'm storing their name and the mail ID. Again, I'm storing the same information in this way. Name colon Ram, email this. Again, name colon Bob, email this. So you can see the data is same for both of the thing, but the storing pattern is different. Okay. The first one, how we are storing the data. If we are storing the data in this format, it's called relational database over here. They're following some tabular based data storage system. I mean, you can see it's a tabular format. Over here, there are some columns. Two columns are there in this scenario. One is name, another one is called email. First of all, we need to set up the table. Table means how many columns should be there. Columns should be fixed first. Name and email should be there. So our tabular structure is fixed. Now I can insert as many record. Suppose I have new employees joining into my company. I'm storing just their name and mail ID over there in this table. So daily basis, I can increase the record counts over here. Okay, this is how we are storing the data in relational database. So we have a fixed tabular structure. Not only fixed, I can change the tabular structure anytime. There is also some scope. Suppose some requirement come that I need to store some other things. I need to store uh, employee's phone number as well. The requirement came into the picture. Then I need to create another column and I need to getting inserted the same columns as well. Okay. But the main things we need to create the main structure of the table, especially columns first. Then when it's fixed, then we'll be trying to insert the data one by one. So it's the feature of relational database. The non-relational database, there is one example I've just provided over here. So we are storing the data value over here in key value format. This is our key, this is our value, key value. Okay. I'll be just going ahead with some more details. Okay. The relational database. What is relational database and all? I'm just mentioning over here with some more details. Relational database or relational database. It's also called relational database management system. In short form, you might have heard RDBMS. Okay. As I mentioned, this relational database, we are storing the data in tabular format only. Okay. So there should be column and records. Records mean rows. Okay. And in the relational database, we'll be setting up relationship between multiple tables. How that is possible? Let me show you the same thing in next picture. This is how we are storing data in relational database management system. There are lots of tables available in the database. Suppose this is the customer table. This is my order table. This is my address table. This is product table. Okay. So how we are setting up relationship? Suppose you can see in the customer table and order table, there are some common columns called order ID. In the customer table, we are having customer ID information, customer date of birth information, order ID related information, address ID related information. I am just mentioning the columns name only for each of the table over here. There should be lots of records. I'm not mentioning records over here. Just to let you know how the relationship should be work over here. So we are having order ID as a common column. So by this order ID, by this common column, we can setting up relationship between customer table and order table. Similarly, with order table and product table, we are having product ID is a common key. Okay. So we can set relationship between product table and order table. We can share information from this product ID. By this product ID, we can set relationship. So I can share price and rating information from here to here by this common key element, common column. Okay. So this common column, it's called primary key or foreign key. The product ID over here in the product table, product ID should be unique in nature. Okay. Suppose in a shopping mall, I'm just naming a particular product. I'm just giving a product ID for that particular product. Okay. Maybe there are lots of product with having the same product ID, but I'm not storing in the product table. I'm storing only one record for each of the product. Suppose I'm having one branded shampoo over here, but that particular shampoo is having lots of quantity, maybe 10, maybe 20 quantities are available in the shopping mall over there now, as of now. Okay. But for the single product, I'm giving one product ID. So I'll be storing in the product information only one times over here. I'll be not duplicating that one. Okay. That means in the product table, each of the table, not only product table, for each of the table, there should be one row identifier, which should be mentioned at the first column. We should be mentioned as the first column. Over here, just like customer. Or maybe I'm having a big software industry. I'm storing each of the employees information in an employee table. Over there, I should be having one employee ID column that should be unique in nature. Maybe I have lots of person having same naming convention. I mean, same name, same first name or same address. So how to identify, how uniquely I can identify that particular customer in that table? I can give employee ID to each of the customer, each of the employees, and that should be unique in nature. No one should be having same employee ID. So in employee table, employee ID is called the primary key. Over here, similar. In product table, product ID should be the primary key. In order table, order ID should be the primary key. Now, while setting up relationship with this product ID and this product ID, I'll be setting the relationship. This product ID is the primary key of the product table, and this product ID is called foreign key in order table. Okay, so I'll be just repeating this key concept again in tomorrow's session, but giving you the example of RDBMS, how to set relationship between two table in relational database management system. This is the way we are setting the relationship. There should be a primary key in a particular table. In product table, product ID is the primary key because this is the uniquely, this particular field should be the identifier one of that particular row. Okay. But in the same, in the table of order, the same column is not the primary key. In order table, or product ID should not be the primary key because in other order, maybe we have one order called 1, 2, 3, 4, having some product ID. In another order, a different customer are purchasing the same product again. Then the product ID can be repetitive in this table. So product ID is not a unique identifier in this particular table, which was a unique identifier in product table. But we need to set relationship between these two tables. So then product ID is working as a foreign key. Over here, it's a primary key. It's a foreign key over here. Similarly, between order table and customer table, in order table, order ID should be a primary key. Okay. In customer table, order ID is there. It is working as a foreign key. So you can join between these two table having this primary key and foreign key, and we can pull the records from this table to this table, and we can set relationship. That is why this is the concept of keys. Okay, we need to maintain those keys from each of the table. We are not
So,
mentioning only the tables. Yeah, someone is telling something. Tell me.
so one question, in a customer table, order ID is a primary key or foreign key? What is?
No, primary key should be unique. In order
Unique.
table,
So,
each of the orders should be unique. Correct.
okay. Okay, got it. Got it. In the customer table, customer ID is the.
Customer ID should be primary key. Correct.
Oh, got it. Yeah.
Similar to address ID as well. Okay. So the concept of primary key and foreign key, I'll be telling the same thing again in details, maybe in tomorrow's session. But this is the concept I'm trying to clear. RDBMS, it's called Relational Database Management System, where we are storing the data in tabular format. There, we are maintaining primary key and foreign keys between tables to set up relationship. Okay. And that is why we are creating relational database management system. We are not only storing in columnar format, we need to also think about this primary key and foreign key concepts so that while storing the data, we can maintain the same way. Any other doubt from anyone? The concept is clear. Whoever is having experience already, they might have know what is primary foreign key. It's very basic, but whoever totally new, please tell me. Okay, I hope no doubt. Moving to the next slide, we are almost 7:30 over here. Yeah. So let me just quickly cover up the next slides. Okay. Yeah. So on top of relational database management system, there are, when we'll be working on top of data, we'll be having this kind of language. It's called structured query language in short form. It's called SQL. Okay. So whatever table we'll be storing in database to retrieve such kind of data or to do joining between multiple tables, any kind of operation on top of relational database, we need to know structured query language. This is one kind of language. Okay, as I mentioned in the syllabus, that maybe after 1 or 2 days, we'll be going at with this language. We should be having the hands-on part. I just put a code snippet over here. No need to worry about it. Who is not knowing the SQL, we'll be learning this thing after 1 or 2 days. When we will be having one relational database handy with us, can just quickly log into this database and we'll be trying to have those kind of coding stuffs. But the language, it's called structured query language, by which we can retrieve the data or create the data inside relational database management system. Okay. Now a bit introduction on top of non-relational data. We're especially focusing on relational database over here because doing the data analytics part, there are lots of advantage, disadvantage using relational database and non-relational database. So the main advantage and but advantageous things on top of non-relational database, why we are using relational database? Because for analytics purpose, data analytics purpose, relational database is in the first choice. Okay. But maybe some reasons are there. We need to retrieve the data quickly. So then we will be using non-relational database. Just I have given some example where I am storing the data in JSON format. JSON is a format of non-relational database, or some of the person they are also telling it semi-structural database, but it's not a fully relational database over here, or it's not a relational database. We cannot say it's a relational database. So this kind of storage pattern with a key value pair, it's not table or columnar format. It's not just like this. It's key value pair. It's semi-structured database. It's called not only SQL. I'm following NoSQL. Okay. NoSQL means not only SQL. We are storing data in this kind of format. Okay. Suppose I'm storing the database. Storing the data somewhere where I need to retrieve it very quickly. So NoSQL is much more faster than SQL. So suppose I need to retrieve a data very quick. Suppose I'm just designing a chatbot. Okay. So whatever I'm just putting the question, they need to answer it quickly. So in the backend of all the answers set, they're using NoSQL database because the data retrieving, it's very much fast in NoSQL. Even over here, we can create this kind of hierarchy. Suppose inside address, you can see street address there, city is there, state, postal code is there. In SQL, the normal tabular structure, I cannot create this kind of hierarchy. I have to create individual column, just like address underscore street address. This should be my columns. Address underscore city. There should not be hierarchy. Address should be my primary column. Inside that, I'll be creating this kind of street address city. There is no such thing in relational database. Okay. In non-relational database, we can create this kind of hierarchical structure over here. Just like phone number, you can see inside phone number, I'm creating some arrays. Again, I'm storing this kind of format. This is called a JSON format of data. Over there are key value. This is one record. Again, I can create another employee's record, first name, last name, all those things over here. Again, within this kind of curly braces. Okay, each of the database, as I mentioned, is having their own specification for different user purpose or different purpose. We are using this thing. As of now, we will not be focusing on NoSQL database over here. Going forward from tomorrow's session, we will be focusing mainly on relational databases because it's easier for data analytics purpose. Over here is another example over here, just like you can see, this is a representation of relational database. We are having ER and revenue. And the same data is been represented by graphs. Okay, it's another, it's not a relational database. It's a graphical, it's not a structural database. It's another way for data representation that I was mentioning. When our data is ready, visualization team will be creating charts and graphs. They'll be just converting this kind of data to this kind of data. This is graphical interpretation of this data. Okay. So this is another way for representing the data. So whatever we will be learning, that same thing we'll be learning while using Power BI. Okay. So now we'll be focusing on relational database, just like this one. And we'll be having, we can also use Excel. The question might be coming in, coming into your mind that why we are not using Excel. Yeah, definitely by Excel, we can use it as a relational database. But we cannot directly go ahead with SQL query and all things over there. Even if we are just going to store the data, maybe more than 1 lakhs data over there in Excel, lots of columns, 1 lakhs data, Excel will not be capable to do that thing. Maybe it's capable, but the things can be hanged. If the data came into Excel with more than that, then that can be hanged. We can definitely use flat file, maybe Excel or CSV file as relational database. Yeah, that is fine, but with low amount of data. Okay. Maybe Excel is one of the source system from where we are pulling the data into ETL tool. Or CSV file, comma separate delimiter should be there. So maybe we'll be taking some data from CSV file. But that can be our source systems as of now. We'll be checking those kind of things, scenarios in our future exercise and all. Okay, Excel part I just tell you, I'm not storing anything, I'm showing anything as of now. Yeah, that's the thing. The main thing I'm just trying to focus over here at the first chapter. That means what are the relational database and non-relational databases as well. Coming forwards, I mean, going forwards, we'll be just focusing on relational databases only. Starting from tomorrow's session, it should be purely relational database. We'll not be focusing on NoSQL and all. If you have some time later, maybe in clouds and all, how we are storing non-relational databases. Maybe there are lots of databases available in market, just like DynamoDB, Cosmos DB. So this kind of database is there to store non-relational database. We can have a quick go through on top of this kind of databases. Maybe in future, maybe at the end of the courses or mid of the courses, I can have one session for that. But mainly we'll be focusing on relational database management system. Okay. Any doubt, any stuck point so far? Because we are almost end of this class for today. Anything? Okay, I hope it's clear.
Yes, as of now, we are good.
Okay, Anvesh. Thank you. Okay, let's connect tomorrow. We have some more details on top of that relational database management system. With some exercise, I mean, not exercise directly, with some examples and all, we'll be quickly checking these things. Some more deeper way. Okay.
Sure. Thank you, sir.
Okay, thank you. Thank you, everyone. Bye bye.
Thank you.
Thank you. Thanks.
16,000 అయిందానికి నిజమా